Hello, welcome to Precision Technologies. I am Venkat. This is part 80 of ASP.NET video series. In this session, we'll discuss about writing custom ASP.NET tracing messages. In part 79 of this video series, we have discussed the basics of ASP.NET tracing. In this session, we'll discuss about writing custom messages to the ASP.NET trace log. And to do that, we have two methods, trace.write and trace.warn. The messages that we write using trace.warn appear in red color, whereas the messages that we write using trace.write appear in black color. That's the only difference between these two methods. But keep in mind this difference between these two methods because this is a very commonly asked ASP.NET interview question. Now let's turn our attention to writing custom messages using these methods. Let's flip to Visual Studio. I have an ASP.NET Web Application project here with Web Form 1, and on this web form I have two text box controls where the user can enter their first and second numbers, and once they click the divide button, we are going to retrieve the numbers from the respective text boxes, convert them into integer, and store in first and second number integer variables. And then we divide those two numbers. Whatever result we get, we are setting that as the text for the message label. And before that we are changing the color to navy. So very simple program. But then when we try to divide these two numbers, there could be a variety of exceptions that can happen. For example, instead of a number, if I enter text, I get a format exception, in which case I want to display a message to the user saying only numbers are allowed. On the other hand, if I enter a very big number that an int 32 variable can hold, then it's going to overflow. So we get an overflow exception, in which case we want to show a message stating number must be between whatever is the minimum value and maximum value that an integer variable supports. And finally, it's illegal to divide a number by zero. It results in infinity. So if we attempt to divide a number by zero, we get a divide by zero exception, in which case we display a message saying that denominator cannot be zero. And then finally, if there is any other exception apart from these three exceptions, then we are showing a message, an unknown problem has occurred, please try later. Okay, a very simple program. Now what we basically want to do is, whenever these exceptions happen, I also want to write, we are displaying this message to the end user, but then I want to write the exception message to the trace log. Okay, let's see how to do that. And as we discussed, all you do is you use the trace method. So trace.write. And then let's say I want to write the exception message. So what's the exception here? For example, I have the format exception, so I'm going to copy that and paste it here, format exception dot message. So I'm using trace.write method for that. For overflow exception, let me use trace.warn method. Trace.warn, and for divide by zero exception, let's also use trace.warn. So divide by zero, and overflow exception, let's copy and paste it here, and along the same lines let's do it for exception as well. So we are logging the exception messages to a trace log file. Okay, when it is a format exception, we are using the write method. In all other cases, we are using the warn method. And let's run this application, make these exceptions occur, and see how the trace messages are actually written. Now for this to happen, we have to enable tracing. Instead of enable tracing at the entire application level, let's just enable tracing at the web form level, and we have discussed about how to do that in the previous session. All we have to do is set the trace element to true. So trace attribute of the page directive to true. That's it. So let's go ahead and run this now. So the web form loads up. We have the trace information at the end of this web form. Now let's go ahead and divide a number. Let's say I want to divide 20 by maybe with 10, and then click divide. We get 2, and look at that. The request type is a postback. Okay, and now let's try to divide the number by 0. Okay, so when I do that, we get an exception. And if you remember, when we get that exception, we are actually trying to write that divide by 0 exception, trying to write it to the trace using trace.one method. And if you remember, any message that we write using trace.one should appear in red color. So let me click divide. So we get an error message here, denominator cannot be 0. That's for the user. But look at that, we get an exception message here, which is returned to the trace log. Okay, attempted to divide by 0. And when did this happen? This happened in the post back event. Why did that happen in the post back event? Because this exception occurred when you clicked the button. So when the post back event was raised, that's when the user attempted to divide by 0, and we have that message there, and it's written in red color. But on the other hand, if you remember the overflow exception, we are writing it using trace, not the overflow, the format exception, we are writing it using trace.write method. So let's see how that appears. Now how to cause the format exception to occur. Instead of entering a number, if I enter something like this, alphabets, these alphabets cannot be converted into an integer, so we get a format exception. So I click that, only numbers are allowed, and then you see that exception message here. Input string was not in a correct format. Okay, again, that's within raise post back event, and that's in black color. Okay, in a later video session we will see how ASP.NET Tracing coupled with writing custom tracing messages like this can actually help us identify very easily the root cause of a performance related issue. So trace.isEnabled property, this is very useful property. Now this property tells us whether if tracing is enabled or disabled. Okay, now let's say if I move this code to production, what's going to happen, this trace.write code will be executed every time a user requests the page, even when tracing is disabled. If I disable tracing on this page, if there is an exception, this piece of code is going to get executed, and I don't want that to happen. If that's the case, then you can use this condition. So if trace.isEnabled, okay, this property is going to return true if tracing is enabled, otherwise it's going to return false. Okay, so this piece of code is going to execute conditionally. Okay, so I don't have to remove this code even if I move it to production. Tomorrow if I enable tracing on the production server in the web.config file, maybe this piece of code will be executed and I'll be able to get the exception message within the trace log on the web server. So if you want to conditionally log or not log trace messages, you can use trace.isEnabled property. Now if you look at this example here in this code, the trace.write method is invoked only if tracing is enabled. If you don't check trace.isEnabled property prior to writing to the trace log using trace.write or trace.warn methods, we don't get an exception. But if we are doing any sort of significant work to build a trace message, then we can avoid that work by actually checking the isEnabled property first, which means before I actually write this message, if I'm doing a lot of work here, maybe I have some loops to get inner exceptions, the exception message, stack trace, and all that details. If I'm doing some processor intensive work here, and if I want that to be executed only when tracing is enabled, which is definitely going to improve the performance of the application, if the tracing is disabled, I don't want this piece of code to be executed. In that case, or you can have this condition. Okay, but even if you don't have this condition, it won't throw an exception if tracing is disabled, but it's just going to consume the processing power of the web server. Okay, if tracing is disabled, we want to slightly improve the performance by not allowing this code to run. So in which case we can use trace.isEnabled property. Now with the classic ASP, the technology that was in existence before ASP.NET, the only option for printing debugging information was response.write. But then there are problems with this approach. Okay, for example, when we use response.write to debug a problem to print out the messages on the web form, even end users can see them. But whereas with tracing, if we set the page output attribute to false, then the trace messages are returned to the trace.axt file, which is accessible only on the local web server. Locally, when you access it locally, only then can you access that trace.axe file. remote users, that's the actual end users, cannot see the trace information. They will see the page as usual. So that problem is solved using tracing as opposed to response.write. And all the response.write statements must be removed now. For example, when I'm debugging the application, I will have these response.writes statements in several pages. After I complete my debugging, I'll have to remove those response.writes from all the pages. Okay, which is a little, laborious work, and it is also error prone. If you forget to remove it at certain pages, then user will see those response.write messages. Okay, but with tracing, all we have to do is turn the flag to off within web.config file. That's it. So we have several advantages of using tracing over response.write. On this slide, you can find resources for ASP.NET, C#, and SQL Server interview questions. That's it for today. Thank you for listening. Have a great day.